Welcome to the ITFreeTraining video on installing Windows 8 from DVD, USB, and from the network. After watching this video, you will be able to install Windows 8 by bringing the media to the computer, by installing it over the network, or anywhere in between. Once you finish watching this video, you will be well on your way to customizing the Windows install process to meet your needs. Why would you need so many options for installing Windows 8? The DVD is the simplest install you can perform. Insert the DVD and perform the install. If, however, you want to make changes to the media before the install, you need to make the changes and burn a new copy of the DVD. If you put the install files on a USB key, it is easier to make changes like adding additional device drivers. However, if you want to perform multiple installs, you need multiple USB keys or multiple DVDs, and keeping them all the same becomes a challenge if you make a lot of changes. Lastly, you have the option to place the install files on the network. This keeps the install files in one place, so it makes change management a lot easier. The disadvantage of each approach is that it complicates the install procedure. If you have a couple of installs to perform, it is easiest to use the DVD or USB. If you are doing a lot of installs, it may be worth your time looking at a network-based installation. Before I get started, I first want to point out that after the DVD and USB install, I will be looking at a completely network-based solution that does not require physical media to be taken to the computer. This provides a simple way of installing Windows 8 on a lot of computers on the network. However, this solution does not provide multicast support. Multicast allows you to transmit the same data across the network to many computers at once. It is a very efficient way of performing multiple installs on the network at once. However, in order to have this functionality, you need to use a commercial system like Windows Deployment Services. Systems like these take a lot to set up, and there are additional costs involved. The solution that I will be looking at will use free software and is simple to configure. However, it does not have multicast support. This video goes into quite a lot of detail and explains each step of each process. If you are only interested in a quick network install and do not need to understand the details, have a look at our other video on installing Windows 8 on the network. This is a quick video which will allow you to perform a complete Windows 8 install from the network, but does not explain how everything works. Before I look at installing Windows 8 using the DVD, USB, and finally the network, I first want to have a look at the install process used to install Windows 8. First, you have boot code, which may also be referred to as a bootstrap or bootloader, amongst other names. This is a small amount of code that is essential to allow an operating system to be loaded. When you boot off a hard disk, for example, there is a small amount of code in the boot sector, which is the first code that is loaded before the operating system is loaded. In the case of the Windows setup, once the boot code has loaded, the next step is to load Windows PE. Windows PE is a lightweight version of Windows. It is not designed to run as an operating system. It does not have enough functionality to run major applications, and in fact, this would break the license agreement if you were to do this. But what it can do is run small applications like rescue tools, and in this case, install Windows 8. Once Windows PE has loaded, the next step is to run the setup files. The setup files are what runs the wizard that installs Windows 8 on the computer. As you will see in this video, each of these steps can be changed. That is, Windows PE could be run from DVD, USB, or the network. The setup files could be located on DVD, USB, or the network. The choice is up to you. By the end of this video, you will see the different parts of the install process can be performed using different media. A common solution is to boot from DVD or USB and have the setup files located on the network, as this is quite simple to do and offers a lot of flexibility. So to start with, let's go with the easiest install of them all, installing Windows 8 from the DVD. I have placed a Windows 8 setup DVD in this computer and started it up. The first step in the install process is Windows PE, which is loaded from the DVD. Windows PE can be loaded from the DVD into memory and run. Once Windows PE is loaded, setup will be run. On the welcome screen, you can change a few options depending on where you are. For example, changing the currency format and the keyboard type. In this case, I will accept the defaults and move on. The next screen allows you to start the install. However, I should also point out the option Repair Your Computer. If you have problems with your computer, for example, Windows will not boot, one option you have is to boot from the install media and select this option and attempt to repair the computer. In this case, I will select the option Install Now and move on. The next screen will ask for the product key, which I will enter in. If you do not have a product key, you can still install Windows 8. However, you will need to obtain a product key by 30 days. Otherwise, the main features in Windows 8 will be disabled until you purchase a product key. On the next screen, the license screen is displayed. I will accept this and move on. The next screen will ask which type of install you want to perform. The top option will upgrade an existing install of Windows 8. Even though this option is available, in order to use this option, you must first boot from the existing operating system and run the setup from this operating system. If you do not do this, selecting the upgrade option will give you a message telling you to do this first. The next option down performs a clean install. Since no operating system exists on this computer, as yet, I will select this option and move on. This screen allows you to select the hard disk to install on and partition the existing hard disk if you wish. To see additional options, select the option Drive option Advanced. If your drive does not appear, you may need to select the option Load Driver to load any additional device drivers. In this case, I will press Next and allow Windows to partition the drive as it sees fit. On the next screen, the files will be copied to the drive. This process takes about 5 to 10 minutes to complete, so I will speed up the video and return shortly. When the files are copied over, you will have the option to restart, or setup will restart by itself after 10 seconds. The computer will now be configured to run Windows 8. The computer may reboot a few times. The process took a few minutes on this computer, so I've sped up the process. Once the process has completed, you will be taken into the initial setup wizard. For the first screen, I will need to enter the computer name. You are best to choose a name that describes what the computer is used for. On the next screen, you can choose if you want to use the default settings or have the option to customize the options that are used. In this case, I will choose the option Customize in order to use all the options that are available. The next screen will ask if you want to turn file sharing on. If you do not need to share any files with anyone else, you do not need to enable file sharing. In this case, this computer will be used with other computers on the network behind a firewall, so I will, in this case, enable file sharing. On the next screen, there are a few more options to configure. The first option allows Windows Update settings to be configured. In most cases, you should leave it on the default option, Automatically install important and recommended updates. This will ensure that the new updates are installed when they become available. In some cases, you may want more control over which updates are installed. For example, you have a slow network connection and you may want to disable Windows updates and install them when required. The next option automatically attempts to obtain information about device drivers and applications from the Internet. If you install any additional drivers on the computer or software, this would be a valuable option to keep on to obtain additional information. The next three options relate to keeping the system secure. These options check for suspicious activity and improve security in Internet Explorer by checking addresses and switching off tracking options. The next screen allows you to provide feedback to Microsoft in regards to how applications are running on the system. It is up to you to decide if you want to provide this feedback or not. The next screen configures if Windows will check online for solutions to problems, for example, an application crashes. It will also automatically attempt to use online information to ensure that known web pages with problems are displayed correctly. Lastly, there is an application setting which allows you to use your account picture and location settings in applications. The next screen allows you to use a Microsoft account to sign in to the computer. If you have one already configured, you can use it here, or you can sign up for a new one. Having Windows linked to an online account means services like SkyDrive are automatically configured to be used with that user, otherwise they would need to be configured. In this case, I do not want to use an online account, so I will use the bottom option, Sign in without a Microsoft account. The next screen will confirm that you either want to use a Microsoft account or a local account. Since I want a local account, I will select the option Local Account and move on. On the next screen, I can enter in the username, password, and a password hint. Once all this is done and I press Finish, the configuration wizard is now complete. Windows will now finish finalizing the configuration for Windows 8. This also involves running a number of performance tests on the computer. The process took around 5 minutes to complete, so I have sped up that process so we do not have to wait. There you have it. Windows 8 has now been installed using the DVD and is ready to go. As you have seen, the DVD install is the easiest to perform. The problem with using the DVD is that it is not the easiest media to make changes to. For example, if you wanted to add additional device drivers to the DVD, you would need to create a new DVD or use a rewritable DVD media. Either way, it is not the fastest way to make changes. The next Windows 8 install I will perform is using a USB key. If you perform these steps manually, you need to ensure the USB key is bootable. In this case, I will use some free software to configure the USB key, so I do not need to worry about this. To create the USB key using the files from the DVD is quite simple. Rather than perform the same process that I performed with the DVD, I'm going to make a few little changes. If you recall, the DVD contains Windows PE and the setup files. It is a simple matter to copy these to a USB key and have the USB key work just like the DVD. Rather than do this, I will instead copy Windows PE to a USB key and copy the setup files to a file share on the network. This will give you a partial network solution. It is partial in that you will still need to take the USB key to the computer to perform the install. However, later in the video, I will show you how to perform a network install without any physical media. Even though this is a partial network solution, the advantage is that the files are easy to update and the only media that you need on the PC is Windows PE. You can make as many copies of Windows PE as you want and thus perform as many installs as you have media, either on a USB key or DVD. One more benefit of separating Windows PE and the install media is that once Windows PE has booted, since it loads in memory, you can remove the media from the computer. You do not need to have the media containing Windows PE available once Windows PE has booted. I will now change to my Windows 8 computer and look at how to configure Windows 8 on the USB key to install Windows 8. On the desktop of this computer, I have two ISO images containing the media for Windows 8 32-bit and 64-bit. Your favorite image burning software should have an option to create an ISO image from a DVD. Otherwise, there is a link in the description of this video to some free ISO creation software which can perform this. Before I configure the USB key, I will first set up a file share containing the install files. To do this, I will right-click the 32-bit version and select the option Mount. Once the ISO has been mounted, I will select all the files and copy them. You could also perform this step by copying the files directly to the DVD. I will then go to the C drive and create a directory called Install Files. In the Install Files directory, I will create a folder called Windows 8 x86. In this folder, I will paste the files from the install media. While the files are being copied over, I will go back to the C drive and share the directory by right-clicking it and then selecting the properties for the directory. From the properties, select the tab Sharing, and then select the option Advanced Sharing. From here, it is just a matter of ticking the tick box Share this folder. From here, you can also configure the permissions for the share. However, the default permission is Read for everyone, which will meet my needs, so I will not need to change them. Once I exit out of here, this is all I need in order to share the folder. The next step is to configure the USB key. To do this, I need a copy of Windows PE. You cannot download Windows PE directly. However, I can create a copy of Windows PE using Windows Assessment and Deployment Kit for Windows 8. To do this, I will open Internet Explorer and Google Windows 8 ADK. If you have trouble finding the link, I will put the link in the description of the video. Once the website has opened, I will click the download link. This will download a small online installer. Once I run this, this will launch the ADK setup. The install is quite simple. In this case, I will accept the default directory for the install. When asked, I will accept the default of No for the Customer Experience Improvement Program, and then accept the license. The next screen will determine which features are installed. The features you select need to be downloaded from the internet, so the more features you select, the longer the install will take. In this case, I need to ensure that Deployment Tools and Windows Pre-Installation Environment, Windows PE, is selected. Once I press Install, the required files will be downloaded and installed. The download takes a while to complete, so I will pause the video and return shortly. Once the download has completed, the next step is to create an ISO containing Windows PE. To do this, I will exit out of here and then press the Windows Start key. From the Start screen, I need to select the icon Deployment and Imaging Tools Environment. This will open a command prompt. However, the difference is that there are a number of variables that are configured that allow the tools to run that I'm about to run. If you attempt to run this command from a regular command prompt, you will most likely get a message saying the command could not be found. The first command that I will run is copy PE. This copies the files required for Windows PE to a directory. The next parameter is x86 for 32-bit, followed by the folder that you want to store the files in. Once I run the command, the files will be copied. There are not too many of them, so it does not take too long. Once the files have been copied, the next step is to put these files in an ISO file. This is done with the command make win PE media. For this command, you need to add /ISO followed by the folder containing the Windows PE files and the location of the ISO file you want to create. In this case, I will save the ISO to the desktop. The command itself takes a minute or so to run, but I've sped it up so we don't have to wait. The next step is to transfer the Windows PE ISO to the USB key. To do this, I will open Internet Explorer and open the website pendrivelinux.com. This is software that copies the install files and configures a USB key for booting. Even though this software is primarily designed for Linux, it works with Windows as well. Once the website opens, all I need to do is select the link for Universal USB Installer. And once the page opens, select the download link at the bottom to download. The good thing with this software is there is no need to install it. It can be run directly from the web page. Once I run the software and accept the license agreement, I next need to install the options that I want to use. From the distribution pull-down, select the option Windows 8 Installer. Even though I will be using Windows PE, the process is the same, so this option will work. Next, I need to select Browse to select the ISO that I want to copy to the USB key. Notice that if I wanted to, I could select the ISO for the Windows 8 DVD. If you just want to get the same result as the DVD but using a USB key, select the ISO for the Windows 8 DVD. In this case, I will select the WinPE ISO that I just created. Once the ISO has been selected, the last step is to select the USB key that you want to write the data to. In this case, my USB contains data already, so I will tick the tick box Format. Once I press the button Create, I will get a message telling me what is about to occur. That is, the USB key will be reformatted and which files will be copied onto it. Once I press Yes, the process will begin. The process takes a few minutes to complete, so I've sped up the video so we do not have to wait. Once complete, I can close all these windows and remove the USB key from the computer. I will now put this USB key in a computer that I want to install Windows 8 on and start that computer up. Before you can perform an install with a USB key, you need to ensure that your computer is configured to boot from USB. On this particular computer, to enter the BIOS, you need to press the Delete key. Once in the BIOS, you need to find the boot options. Different BIOSes will have the boot options in different places. In this particular BIOS, the boot setting can be found under Advanced BIOS Features. Once in Advanced Features, the next option I need to select is Hard Disk Boot Priority. Notice that my USB key is second in the boot order, so I will need to change it so it is first. Once this is complete, I can exit out of here and then save the settings and exit the BIOS. The computer will now start up, and rather than booting from the hard disk, it will boot from the USB key instead. Windows PE will now be loaded up and placed into memory and executed. Once it has loaded, you are free to remove the USB key from the computer if you wish. Notice that when Windows PE boots up to the command prompt, a command called wpe-init is running. What this does is that it installs additional plug-and-play device drivers and starts up networking. It does not take long until it finishes running, and I have access to the command prompt. To install Windows 8, I will first run the netuse command to map a network drive to the install files directory that I shared previously. Netuse will ask me for a username and password. Once I have entered in this, the drive will be mapped. I next need to change the directory to the directory containing the install files and run setup. Notice that once setup runs, the wizard will run just like it did when Windows 8 was installed from the DVD. I won't go through the process again since it will be the same as it was when I ran the setup from the DVD. However, you should get the idea of how the install files can be separated from Windows PE. Currently, the media is still required to be taken to the computer in order to perform the install, that is, a DVD or a USB key. I will now look at how you can perform the whole process over the network without the need to take any physical media to the target computer. So, how do you perform the whole Windows 8 install process over the network without the need for physical media? Let's consider a desktop computer on the network. The first step is for the computer to obtain some boot code. With the DVD and USB install, we did not need to worry about this because the DVD already contains the boot code, and the USB creation software takes care of this step for us. But in this case, we need to have the boot code, and we need to deliver it over the network to the desktop computer so it can execute it. To do this, a computer or device needs to be configured that is running TFTP, or Trivial File Transfer Protocol. Trivial File Transfer Protocol is a lightweight version of FTP, or File Transfer Protocol. It does not include a lot of the features of FTP. Most noticeably missing are security features like usernames and passwords. Since it does not contain a lot of features, the code for TFTP is very small. This makes it a great choice for embedded devices like network cards. Using TFTP with a minimal amount of embedded software, a network card can obtain the boot code from the network. TFTP is a common choice in diskless workstations due to its small size. Since in this case it is only being used to read boot files from the network, having no security in TFTP is not a problem. Now that the boot code has been transferred over the network, the next step is to get Windows PE to the desktop. The same process can be performed as with the boot code. Windows PE is made available via TFTP, and then copied to the desktop. You may be thinking, could I also make the Windows 8 setup ISO available using the same method? This can also be done, but the problem is that the whole DVD must be copied across the network and then stored in the memory of the desktop. Depending on which DVD you use, this may require over 3 GB of memory. This means that in order to perform the Windows 8 install on the desktop needs to have at least 4 GB of memory, if not more, which limits which desktops you can install it on. In this case, I will choose to separate Windows PE from the install files like I did with the USB key install. The desktop will obtain these files from a file share and copy them over the network as required. Since the Windows PE ISO is around 200 megabytes, this will significantly reduce the RAM requirements for installing Windows 8 over the computer. I will now change to my Windows 8 computer to look at how to perform a complete install of Windows 8 over the network. Windows does not come with any software to provide TFTP services. However, there is a lot of free software that will allow Windows to perform this service. If I open Internet Explorer, I will perform a Google search for TFTP D32. This software not only provides TFTP services, but also includes other services like DHCP. There are some additional options that need to be configured in DHCP to allow network booting. The advantage of this software is that these settings are configured automatically for you. Later in this video, I will look at how to add these settings to Windows DHCP if you would prefer to use Windows DHCP. Once the page is loaded, I next need to select Download and then scroll down to the downloads. There is an installer which will install the software on the system. However, in this case, I will download the zip file for the 64-bit version. This is a standalone version that I can run at any time without having to install it. In this case, I will save it to the desktop. Once saved, I will right-click the file and select the Extract All option, and then decompress all the files to the desktop. In this folder is the file TFTPD64, which is the executable which I need to run. Notice that since the software is standalone, I can run it without having to install it. If I want to remove the software later on, all I need to do is remove the folder. Once the software is running, I will next press the Settings button to configure it. To configure the TFTP files, I need to select the tab TFTP. First of all, I need to select a base directory for the TFTP to distribute files. I will do this by pressing the Browse button and then creating a directory on the C drive called TFTP. Once created, I will go back to the Settings screen and tick the option PXE Compatibility. The network card uses a system called PXE, or Pre-Boot Execution Environment, in order to obtain an executable software downloaded from the network. Ticking this option will improve compatibility with PXE network cards. However, your network card may still work without this option ticked. Next, I need to select the DHCP tab and configure the options for the DHCP server. In this case, I will configure a starting IP address and 50 IP addresses for the DHCP server to be allocated to clients on the network. For the boot file, I will enter in pxelinux.0. This is a free Linux bootstrap software that will allow me to download the Windows PE ISO from the network. I have not downloaded and configured this software yet, but I will soon. Next, I need to configure the other settings for DHCP. These are the default router, network mask, and DNS server. You can see this software can easily function as a fully capable DHCP server. Now that the DHCP server has been configured, I will now close the settings and open Internet Explorer again. I next need to download software to provide network booting. If you do not want to download and configure these files yourself, I have zipped up the files and left a link for these files in the description of the video to save you having to do the work again. In this case, I will Google PXE Linux. PXE Linux is part of SysLinux, so you will see that the first web page is SysLinux, which I will open. Notice that in the taskbar, there is a security alert for Windows Firewall. I will press Allow Access as this is required to allow TFTPD to access the network. On the web page, there is a lot of information, so to find the download section, I will search for the keyword download. Notice that on this line there is a link for downloads, which I will select. There is a long list of downloads, but they are all essentially the same, just different versions compressed differently. I will scroll down to the bottom and select the latest version available, making sure I select the zip file so I can decompress it easily in Windows. Once selected, I will save the file to the desktop. Once the download has completed, I will extract the contents to the desktop. As you can see, there are a lot of files. However, there are only 5 files that I need to copy. To do this, I will open another copy of Windows Explorer and go to the TFTP directory that I created earlier. The first file that I need to locate is the BIOS directory. In the BIOS directory, I next need to open the core directory. In the core directory, I will locate the file pxelinux.0 and copy this to the TFTP directory. If you remember earlier, this is the file that I configured in the DHCP settings in the TFTPD software. This file is the first file that is downloaded to the client over the network and provides the core bootstrap code that allows us to perform other functions over the network. The next file that I need to copy is found under the BIOS directory once again, but this time I need to navigate down to the COM32 directory, and then down to the ELF-link directory, and finally the LD Linux directory. The file that I want to copy is the ldlinux.c32. This file is the bootloader. If you are familiar with Windows, this file is the Linux equivalent to the bootloader used in Windows systems called ntloader in Windows XP or winload used after Windows XP. This means, so far, I have copied the bootstrap file which will load the bootloader. Next, I need to go back to the COM32 directory and open the directory libutil. In this directory, I need to copy the file libutil.c32. This is a library file that contains functionality required by one of the other modules that I will copy over. The next file that I will copy over is memdisk. This is located under the BIOS directory, under the subdirectory memdisk. Memdisk creates a virtual disk in memory. It is this virtual disk that will be used to store and run Windows PE. The last file that I need to copy is found under BIOS, COM32, menu directory. In this directory is the file menu.c32. This file will provide a text-based interface for the bootloader. This will allow the bootloader to display a menu to the user that will allow them to select the operating system that they want to boot. In this particular case, I will configure the bootloader to have an option for a 32-bit install and a 64-bit install. Now that I've copied over the required files, I will next need to create some configuration files. Before I create these, I need to create a directory called pxelinux.config. The bootloader by default will look in this folder for the configuration files. To create a file that I can use, I will open Charms and then search for the command prompt. I need to create a file with no extension, so a little trick that I like to do is to run the command echo greater than followed by the file name with no spaces. What this does is creates a file with the extension given. It is difficult to create an empty file using Windows Explorer unless you change some of the display settings. Now that the file is created, I will next run Notepad to edit the file. The first line that I need to enter in is default followed by menu.c32. This setting determines the default option that will be loaded if none are selected. This may not make sense to use the setting menu.c32 in this case, but it will all make sense in a moment. The next line is prompt 0. This essentially states wait for 0 seconds and then use the default option. So what do these two lines mean? As soon as the bootloader loads up, the default option of loading the menu will be performed. In the configuration file, I next need to enter in the configuration that will be used for the text menu. The first line is the menu title, which will allow me to configure a title to display at the top of the screen. The next setting that I will enter in is timeout 600. This indicates how long the menu will be displayed before the option is automatically selected. This is in tenths of seconds, so 600 will be 60 seconds. Now I need to enter the configuration options for the menu items. To do this, I will use label followed by a description of the menu item. This is what will be displayed to the user on the menu. Next, I need to enter in some boot options. The first is Linux/memdisk. This will load the module required for the virtual disk. The virtual disk will be used to store Windows PE. The next command, initrd, loads up a file system into a RAM disk. So in this case, I will enter in the file name for the Windows PE 32-bit ISO. So essentially, these two lines load up the module for the RAM disk and then put the Windows PE operating system into this RAM disk and run it. The last setting I need to add is append ISO raw. This changes the way the ISO is read by the Linux bootloader. Sometimes the bootloader may have problems reading Windows ISOs, and this option needs to be added. This is the configuration done for the 32-bit version. I will next add the configuration for the 64-bit version. It is the same as the 32-bit version, however the name of the ISO has changed to the 64-bit ISO, and the label has changed to indicate that it is the 64-bit version. This is all the configuration that is required. I will now close the file and save it. So far, I have created only the Windows PE boot disk for 32-bit operating systems. I will now create a Windows PE disk for 64-bit operating systems. If you remember when I created the 32-bit Windows PE ISO and used it for USB install, I needed to manually map a drive to the setup files and run the setup. When I create the 64-bit Windows PE ISO, I will add a script to the ISO so that the process happens automatically. To do this, I will press the Windows key and then right-click the Deployment and Imaging Tools icon. Right-clicking the icon gives me additional options at the bottom. In this case, I want to select the option to run as an administrator. Running Deployment and Imaging Tools sets some configuration variables needed for the commands I am about to run. Administrator rights are not required for the creation of the ISO, but I do require administrator rights to run the mount command, which I will use to modify the Windows PE files. Like when I created the Windows PE 32-bit ISO, I will run the command copy PE AMD64 followed by the directory I want the files to be copied to. Once the command is run, all the required files for Windows PE 64-bit will be copied into this directory. Once the files have been copied, the next command I will run is imagex with the following parameters. The first parameter, mountrw, tells imagex to mount the image file to a directory with read-write access. This will allow me to make changes. The next parameter is the location of the image file that I want to modify. Notice that the file I am modifying is called boot.wim. This is an imagex file that contains all the Windows PE operating system files. The next parameter is 1. ImageX files contain multiple images. The 1 simply states, use the first image found in the file. In the case of this image file, there is only one image file in the image. The last parameter that I need to enter in is a directory in which to mount the ImageX file. When I run this command, this will mount the ImageX file to this directory so that I can change any file using tools like Windows Explorer. The process of mounting the image took just over a minute, so I have sped up the video. Now that the image has been mounted, I can now change to the Mount directory and then go to the System32 directory under the Windows directory. In this directory, I will use the echo command to create a file called startnet.command. This file is run automatically when Windows PE starts up, so it is a good place to put the commands that I want to run. I will next edit the file using Notepad. The first command I will run is @echo_off. This disables the local echo so that when commands are run, the command prompt will not show the command, only the output of the command. The next command I will run is wpe-init. You may remember that when Windows PE booted using the Windows 32-bit version, this command was run. This command initializes the networking on the computer. When you create the file startnet, this prevents this command from running, so you have to run it manually if you want network support. The command runs in the background and takes around 10 seconds to complete. I need to wait for this to finish before I can run any networking functions. To wait for this, I will run the command timeout20 found in the Windows System32 directory. This will pause execution for the script for about 20 seconds. Networking takes around 10 seconds, but waiting for 20 seconds will make sure it has enough time to start and configure itself. The next command I will run is the netuse command to map a drive to the network share that is holding my install files. Finally, the last command that I will run is the setup command from the network share. This completes the script, so I will save the changes and close Notepad. The command timeout is not included in Windows PE, so I will copy this from the local Windows install to Windows PE. If you decide to do this, make sure the file is the correct architecture. If you mix the 32-bit and 64-bit versions, the command will not run. All the changes that I want to make have been made. I will now commit the changes by running image_x followed by the /unmount parameter, the folder that I mounted the image to, and finally the parameter commit. The process of committing and unmounts takes a minute or so, so I will pause the video and return shortly. The last command that I need to run is make win_pe_media with the parameter /ISO followed by the folder with the Windows PE files in it and the file name that I want to export the ISO to. This command takes a minute or so to build the ISO image. Once the ISO is created, I will close some of these windows and then copy the two Windows PE ISO images to the TFTP directory. This will be downloaded using the network to the client computer and stored in the RAM disk. The last step that I need to do is copy the setup files to the shared directory for the 64-bit install. To do this, I will create a separate directory in the C drive under Install Files. I will then mount the ISO containing the setup files on it by right-clicking it and selecting Mount. Once the ISO containing the install files has been mounted, I will copy the setup files from the local shared directory. This process does take a few minutes to complete, so I'll pause the video and return shortly. Everything is now configured to install Windows 8 over the network. I will change to another computer on the network to start a Windows 8 install. Notice on this computer there is an option to press F12 for a network boot. A lot of BIOSes have this option. You just need to have a look when the BIOS screen appears to determine the correct key to press. Once F12 is pressed, the computer will attempt to boot from the network. Notice that it will automatically obtain an IP address and automatically download PXE Linux. Once loaded, the menu screen will appear. The 64-bit and 32-bit options will appear. In this case, I will select Windows 8 64-bit. You could also add recovery DVDs here to the menu if you wanted to. When selected, notice the memdisk module will load, and then Windows PE 64-bit ISO will be downloaded from the network to the local computer. If I change to my Windows 8 computer that is running TFTPD, notice that a dialog has appeared showing how much of the transfer has completed. Windows PE is 200 megabytes in size, so your network speed will determine how long it will take to transfer. I will now change back to the other computer. Notice you cannot tell how long it is going to take, and the computer appears to have frozen, but it is downloading. I will now pause the video and return when it has almost completed downloading Windows PE. This computer already contains an operating system. Notice that I get a message saying, press any key to boot from CD or DVD. Since Windows PE has detected an operating system already, it gives you the choice to boot from the existing operating system rather than booting from Windows PE. Since this is not what I want, I will press a key and start the Windows PE boot disk. Windows PE will now start up. You will notice the process is the same as when it was performed using the DVD or USB. The only thing that has changed is how Windows PE was made available to the computer via the network. Once Windows PE has loaded up, notice from the title of the command prompt that StartNet is running and WPE init is not. This is why WPE init had to be run from StartNet. Otherwise, it would not be run at all, and thus there would have been no network support. Notice also the countdown from the timeout command is running to allow time for networking to start before any network commands are run. Next, I will get a message stating the command completed successfully, indicating the network drive was mapped to the install drives. After this, the setup will be run. Notice that the setup is the same as if I booted from the DVD. All files, however, are stored on the network, and no physical media was needed to be brought to the computer. This covers how to install Windows 8 from the network. However, if you are using a production network that uses Microsoft DHCP server, you may want to make some changes to your existing DHCP rather than using the DHCP server that comes with TFTPD. Before I can look at how to make the changes to my existing DHCP infrastructure, I first need to go to my Windows 8 computer and close TFTPD, as this will stop the DHCP server. This will also stop TFTP services as well. However, I will configure this again on my Windows server. I will now change to my Windows 2012 server and start configuring it for installing Windows 8 from the network. Windows Server does not come with a TFTP server, so one needs to be installed. I will once again install TFTPD, but this time I will install it as a service rather than having it run as a standalone application. First of all, I will download TFTPD32 by searching for it in Google and selecting the download link on their webpage. From the downloads, I will select the option for Service Edition and run the install from the webpage. From the setup, I will accept the license and then from the install options, tick the option to start service and move on. On the next screen, I will accept the default install location and complete the install. Once the install is complete, I will be given a message telling me that I need to configure the firewall on the server. To do this, I will close all these windows and then move the mouse to the top right of the screen to open Charms, select Settings, and then select Control Panel. Once the Control Panel is open, I will search for Firewall and open it. From here, I will select the option for Advanced Settings. The rule that I'm about to create, I could also create using the standard Windows Firewall dialog. However, if you use Windows Firewall with Advanced Security, this will give you more options and greater security. To create the rule, I will right-click on Inbound Rules and select the option New Rule. From the wizard, I will select the option Custom. This will give me additional options for creating the firewall rule. On the next screen, I will select the option This Program Path and then browse to the location of the executable. Once selected, this will ensure that only network traffic will go to this executable. This prevents other software like malware being installed on the computer and using this rule to send and receive their own traffic. Since the software that I'm using runs as a service, I will also select the Customize option next to Services to configure additional security. On this screen, I will select the option Apply to Services Only. This will ensure that network traffic can only be used by software that has been installed as a service. Now that all the program options have been configured, I will move on to the next screen. On this screen, I can configure the protocol and ports used. TFTP uses the protocol UDP, so I will select this at the top. Under this, I can select the local port, which is 69 in the case of TFTP. This will ensure that any other network traffic that is not TFTP traffic will be blocked. On the next screen, I can configure which local and remote IP addresses can be used that I want to allow. If you are only using TFTP to install onto local clients, you could add the local subnet here for remote IP addresses for additional security. The next screen determines if the traffic is to be allowed or blocked. In this case, the traffic needs to be accepted, so I will leave it on the default option of Allow the connection and move on. The next screen decides which profile you want to use. If the server will always be a domain member, you can deselect the option for private and public. In this case, I will leave them selected and move on. On the last screen of the wizard, I need to enter in a name for the new rule. I will enter in a descriptive name for the service and press Finish to complete the wizard. The firewall is now configured. The next step is to create a directory to store the TFTP files in. So I will open Windows Explorer, navigate to the C drive, and create a directory called TFTP. The next step is to configure TFTPD, so I will launch the admin software from the desktop. Once open, I will press the button Settings. In this case, the only service that I will be using is TFTP, so I will deselect all the other services. The next step is to select the TFTP tab. On this tab, I will configure the base directory to the directory that I just created. The other option that I will configure is PXE compatibility. This changes a few settings for better PXE compatibility. However, in a lot of cases, network booting will work fine without this option. If you do experience problems, make sure this setting is configured, as this may fix the problem. When I press OK, I will get a message telling me the service needs to be restarted. So I will acknowledge this message and go to the control panel and perform a search for services. In services, I will find the TFTPD service and restart it. Once the service is restarted, I will close some of these windows. I will get an error message from the TFTPD admin tool that the service was terminated. This is normal, as I should have closed the admin tool before restarting the service, so it is safe to close this message and ignore it. I need to put the required files into the TFTP directory. I have placed these in the ITFreeTraining website, so I will enter in the address, link it in the description of this video, open the zip file, and copy the files into the local TFTP directory. I will also need to copy the Windows PE ISO images. These are created earlier in the video and have copied to the desktop. I now will copy these from the desktop and place them in the TFTP directory. I cannot make these available for download due to them being copyrighted. The TFTP service has now been configured and has the required files in it. I next need to configure DHCP. To do this, I will run Server Manager from the Quick Launch bar. From Server Manager, I will select the pull-down menu Tools and then select DHCP. Notice that when I select NYDC1, the DHCP server is not available. This is because I stopped it before, as this would have conflicted with the demonstration earlier that I did using Windows 8. I will now right-click the DHCP server and select All Task and then select Start. Once the DHCP service is started up, I will add 2 additional options to DHCP. These are required in networking booting. These were not required in the demonstration before, as the DHCP server included in TFTPD included these options automatically. If I expand down to Server Options under IPv4 and right-click on this and select Configure Options, this will display all the options that can be configured. There are a lot of options here, but the 2 that I'm interested in are options 66 and 67. Option 66, Boot Server Host Name, needs to be configured with the server or device that has the TFTP service running on it. In this case, I need to enter in the IP address of NYDC1, which is this server. For option 67, Boot File Name, I need to enter in the name of the file that contains the Linux network boot software, which is pxelinux.0. Once these are entered, I can press OK to save the options, and now the DHCP and TFTP service are configured and ready for networking booting. If I now start up another computer on my network and press F12 to boot off the network, notice that just as before, the computer will boot from the network and I will get the same menu options that I got when I booted using Windows 8 to provide DHCP and TFTP services. But in this case, the DHCP settings are coming from a Windows server and the TFTP files from the same server. This has been quite a long video, and I congratulate you if you have watched the whole video. I hope you've learned a lot about the Windows 8 install process and how it can be customized for your needs. If you liked this video, please give us a like on YouTube, as this helps us a lot, and check out the other free videos from us. Thanks for watching, and see you next time.